All right, so our next topic, topic one, module one, topic A, lesson four, we're looking at interpreting graphs. And a lot of people I know when we teach graphing, they say, why do we bother graphing? And I would argue that if you don't have a context, a situation that you're looking at, I would agree that the graph doesn't have a whole lot of meaning. But in graphing it, and then not only that, interpreting it is going to be the next skill that we're talking about. So that's why our objective today, interpreting graphs, is going to be at the topic of this launch. And this is the graph that we're going to take a look at. So this is our water consumption in a typical school day. So if you can see, there's always water being used. And we talk about consuming, we don't mean like drinking, we just mean used. The water is being used. So there's always water being used throughout the day. But the spikes that we see, we got to interpret that and kind of how can we use that information? And we're going to use that information in a couple of different ways. The x-axis we can see that's our time of day. The y-axis is left kind of to interpretation, but through some conversations, we figured out that that's gallons used in that minute. So this kind of peak right here talks about how many gallons are being used in that minute time frame. And we can see the spikes. We can make predictions that that's maybe passing times, toilet flushes, and all those kinds of things. So let's actually jump into figuring some things out. So here's a situation we're going to take a peek at, and we can actually figure out more than just looking at water consumption. We can figure out a lot more things with obviously some information. So if we look at this question, it says the bulk of the water is from flushing. So again, little drinks of water here and there, not too bad, but flushes 2.5 gallons of water per flush. That's going to be a piece of information we're going to need. And the estimation is that about 2% of the population is using the bathroom or the restroom or flushing toilets in this 10 o'clock little window. So this right here, this number represents 2% of the population, and our prediction is that that's 80 flushes or 80 gallons. Okay, so 80 gallons of water is used in that time frame, and we're going to use this information to predict the population. So the first thing we've got to do is that's gallons of water. So let's figure out how many flushes that is, and that's where we're going to figure out that there's 2.5 gallons of water per flush. So if I divide that by 2.5, that's going to give me the number 32. And remember that that's flushes. And keep in mind, we've got some assumptions that we're making. If there's 32 flushes, I'm going to also assume that that's 32 people. We're going to assume everybody flushed once. And go from there. So there's that we're predicting that that's 32 people that flush the toilet in that time frame. And the prediction again, we have some assumptions that are being made, but that's approximately 2% of the population. And there's all kinds of ways you could use proportions, you can use logic, but 2% means 2 out of 100. Well, if we think of 2 out of 100, we've got to multiply that number by 50 in order to get the total population. So this 32 people represents 2 of the 100 people of the 100% population. So take 32 times 100, or sorry, times 50, which equals 1600, and that is our approximate school population. The second calculation that we're going to make here is, are we able to, so it says if everyone at the school were to flush the toilet at the same time, how much water would go down the drain? Assuming this is even possible. If everybody flushed it at once, there'd be this crazy amount of water flushing through the pipes. Well, we already figured out that the population is about 1,600 people. So that would also be 1,600 flushes if everybody did it at once. And we knew from the previous slide that there are 2.5 gallons per flush. So just multiply that out, and that comes out to be 4,000 gallons of water. And 4,000 gallons of water total. So again, if that's even possible, because again, all kinds of water would be flushing through the system. Other things that you can do, again, graphs can tell us a lot of information. We could make a guess as to how many toilets there are just based on how many spikes there are. I'm guessing around 80. Make a guess as to how many students are at the school. Again, we've done that based on the percentages. There's all kinds of things that we can do that we can interpret or we can figure out from graphs. Other things, assuming that each flush is 2.5 gallons, estimate the amount of water during each peak. Well, again, that we just go back to our graph and figure out that's how many flushes, just multiply by 2.5. So the most it's ever reached is 100 times 2.5 or 2.5, and we could figure out there's about 250 in that window. So there's all kinds of things that graphs can do for us, which is why we study graphs. What time of day do breaks occur? Again, that's really easy to see. We know that any one of these peaks has to be a passing period. These are all, a couple people, maybe like an enrichment or something like that. But little bit of water usage, all these spikes has to be a passing time. And the final one, what would our school look like? Well, remember our schedules changed a little bit, so I guess that would depend on the day. But each one of those peaks would happen at a passing time, which first hour ends at 8:36. So we know that that's where that would be. So we can use graphs to communicate information, and we can also determine information from graphs.